In example 13.2, we're going to take the two spheres from the previous example and place them out in space. They're initially held at a position such that their centers are a distance of 0.05 meters apart, and then they're released. At the moment they're released, we'd like to calculate their accelerations. So the two equations that we'll need for this problem are Newton's theory of gravity, equation 13.1, and Newton's second law, from which we can calculate the accelerations. We already calculated the force between these spheres in the previous problem, and it was this small value, 1.33 times 10 to the minus 10. This is only the magnitude of the force. The gravitational force is always attractive, so the directions are shown. This sphere feels a force F sub g to the right, and this sphere feels exactly the same force to the left by Newton's third law. Given these forces, we can now calculate the magnitudes of the accelerations by simply dividing by the masses as shown. We note that this acceleration is about 50 times bigger than this one because the mass is 50 times smaller. We also note that the acceleration in this problem is not a constant. These values that we calculated are only valid for the moment that the spheres are released. Once they begin to move towards each other, the gravitational force grows and the accelerations will also grow. And this ends example 13.2.